Sleep is defined as a natural periodic state of rest for the mind and body, in which the eyes usually close and consciousness is completely or partially lost, so that there is a decrease in bodily movement and responsiveness to external stimuli.
Megan has now entered the first stage of the sleep cycle. She is between being awake and asleep, or is in a state of very light sleep. Her brain waves slow down and her eyes and muscles relax. Megan is now in stage 2. As you can see, she has entered a slightly deeper sleep. Her body temperature has dropped and her heart rate has slowed down. Her brain activity has decreased.
Megan is now in stage 3, a state of deep and restorative sleep known as slow wave sleep, or what is called delta sleep. The muscles relax, the supply of blood to the muscles increases, and the body repairs and grows tissue. Hormones are released and energy stores are replenished.
REM sleep is defined as rapid eye movement. REM is a unique phase of sleep where random rapid eye movements occur and are accompanied by low muscle tone throughout the body, and dreams appear more vividly. The brain goes through several changes to be similar to the awake activity. Increased blood pressure, heart rate, brain oxygen consumption, and breathing rates. Now that Megan has officially entered REM sleep, we can actually go inside her brain and see what's going on.
Do you ever look at someone and wonder what is going on inside their head?
Megan's asleep. Perfect, she's sleeping. As you can see, we have heavily sedated Megan to coax her into a REM sleep cycle so that we can see what's really going on inside her head. I mean, she's in a naturally occurring state of sleep. Now I will place this mind transfer contraption on her head.
Oh no, it is Obama.
Now I don't know if there's any scientific way that we can possibly explain what we just saw, but we can try.
The hypothalamus is a center for sleep regulation, with hypothalamic neurotransmitter systems providing a framework for therapeutic advances. It contains groups of nerve cells that act as control centers affecting sleep and arousal. Within the hypothalamus is the suprachiasmatic nucleus, the SCN, clusters of thousands of cells that receive information about light exposure directly from your eyes and control your behavioral rhythm.
Next, we'll be visiting the brainstem. The brainstem communicates with the hypothalamus to control between wake and sleep. This includes pons, medulla, and midbrain. Self-promoting cells within the hypothalamus and the brainstem produce a chemical called GABA, reducing the activity of arousal centers in the hypothalamus and the brainstem. The brainstem plays a role in the REM sleep. It sends signals to relax muscles, essential for body posture and limb movement.
The thalamus acts to relay information to and from the senses to the cerebral cortex. During the stages of sleep, the thalamus can be active or quiet. The first stages of sleep is when the thalamus is quiet, allowing for the brain to tune out all the external senses. Once the brain has entered REM sleep, the thalamus becomes active again. The thalamus is responsible for sending cortex images, sounds, and other sensations that are responsible for dreams. We can blame this part for everything we just saw a little while ago.
The amygdala is the most active during REM sleep. Transit activation of the amygdala provides psychological support for the participation of the amygdala in emotional expression, in the emotional content of dreams, and the reactivation and depth of emotional memories during REM sleep, as well as emotional regulation, like remembering dreams the next day. And its possible role between REM sleep and such sleep disorders as nightmares, anxiety, and post-traumatic sleep disorder. Increased activation of human amygdala is locked to REM.
The prefrontal cortex is a wonderful part of the brain that works alongside the hippocampus to learn new skills through memory and practice. Sleep affects the ability to remember information in both these parts of the brain. When the brain is in REM sleep, it recalls all the information retained that day. The prefrontal cortex is low activity during REM sleep. This would account for the weird and illogical things that occur during dreams. This is why we saw Shrek riding a corn dog and didn't even think twice about it.
The hippocampus contributes to dreaming in the context of its association with memory. Activity seems to specifically support memory consolidation during sleep, though a specific coordinated neurophysiological event such as low slow waves, spindles, ripples that would facilitate the integration of new information into pre-existing parietal networks. Sensory areas of the cortex go through the hippocampus and cycle through them like a sorting center. Remembering dreams and facts is associated with the strengthening of the hippocampus by cycling through the memories and storing them in the long-term memory.
Here we have the lobes, the right and the left. The right temporal lobe is the portion of the brain that displays the dream, shown by the blood flow and the electrophysiological stimulation shown by red. The right hemisphere uses a form of visual, spatial, and emotional language, which creates themes and images of the dream through remembered emotions. These dreams are called lateralized memories. Left temporal lobe. The left hemisphere of the brain must access the memories of the right hemisphere. The person is asked to describe a dream or even remember it. To access the memory banks of the right hemisphere, the left hemisphere must connect with amygdala.
In conclusion, Megan is starting to leave the end of the sleep cycle and begin the awake phase. We gotta get out of here.